A DevOps pioneer is a security advocate in the healthcare industry and provides assistance to organizations that are looking to integrate security into the DevOps practices. He has worked to streamline development pipelines and practices for many Fortune 50 companies by focusing on culture and technique. He uses this expertise to surface the right technology to serve business goals and support outcomes. He's going to give us a deep understanding on how to crush the new silos created by DevSecOps and discuss how security is simply an attribute of quality. If we treat it as such, then the DevSecOps call to action that security is everyone's responsibility can truly be realized in a DevOps world. Ladies and gentlemen, it's now time to hear it from a global leader, DJ Schleen, taking charge of his screens right now.
Hey everybody, I'm DJ Schleen, and I'm really happy to be here today at DevOps India Summit. Today I'll be talking about security and DevOps and just how I believe that it's simply an attribute of quality. I'm the Vice President of Infrastructure and Developer Operations at a company called VillageMD, and I'm also co-founder of an open source collective called DKFM. And we'll be talking a little bit about some of the ways that we can address security concerns without necessarily siloing our security into another organizational unit. So I'm going to start off with a quote from Edwards Deming. Quality is pride in one's workmanship. And when we think about Deming, he went to Toyota and Japan after World War II, and he influenced a lot of the recovery of the country as they started modernizing and getting everything back together after the war. And one of the things that he did with his manufacturing processes is he influenced quality, especially when it came to car manufacturing at Toyota. And one of the reasons why, we had Toyota coming into America back in the late 70s was because, and 80s, it was because of the quality of the cars. And they ended up taking over a lot of the US market. And it really got Ford and GM and a lot of other car manufacturers here, got their attention. And that's why they ended up starting to get more quality in their cars as well. So very competitive. And what ends up happening with this quality is as they manufactured cars, they really looked at the quality of the parts, the investigations, and the quality assurance during the process, and made sure that as things were going down the assembly line, if there was a problem, they would stop the assembly line and address it right away. So this is one of Edwards Deming's ideas as he detailed the manufacturing process. He talked about generation of ideas and customer research and how that goes into design of products. The information goes out to the suppliers, and the suppliers get product back in. Those materials and supplier provided parts are tested. And that could be security testing or safety testing of those parts that come in. We've got production, assembly. Now, all of this really looks like the SDLC and what we're doing in DevOps, right? And with CI/CD, this came out in the 50s. And really what we're doing with DevOps is we're getting back to these lean manufacturing concepts where we think about quality in our products as we put them out to production. So, what does this have to do with security? Well, let's take a step back and take a look at some of the features that were added to automobiles over time. When we started manufacturing cars, there wasn't a lot of safety equipment inside of them. These things, if you look at the Ford Model T, safety equipment in it, no, you fell out of the car, right? There was maybe a horn that you could beep, and of course headlights that you could illuminate at night. These are, again, elements of safety, but airbags were only introduced in 1981 inside of automobiles. And they have a history that comes back to, the early 1900s when a few dentists invented this kind of inflatable bladder. And then it wasn't until 1981 where they became optional equipment. Mercedes-Benz came out and gave put them as optional equipment in their cars. And then Porsche came out with the 944 and said, hey, these are standard equipment on some of our vehicles. And then we start looking at high-mounted brake lights. These only came out in 1986. And this was a safety precaution to ensure that, people following a car as it's going down the road, this is the third brake light. So it gives an extra warning at a higher level where your eyes actually hit to, stop or slow down the person behind. Now, this was an element of safety that was put into these cars, helped reduce the amount of rear end collisions. And, did automakers make a separate assembly line to add these components into their cars? No, they didn't. They put these parts, and there was just part of their supply chain coming in to the automobile manufacturing process, and they were put in along the assembly line. They were checked to make sure that they were functional. They were checked to make sure they were installed correctly. So again, elements of safety and elements of quality. And safety we can really put into the security realm. So this brings me to DevSecOps. And I noticed over the past couple of years that it's really become siloed. And it goes back to 10 years ago, DevOps coming into the scene. 6 or 7 years ago, we had a lot of focus on integrating security into that DevOps process. Fast forward to 2021, it turns out that application security teams or traditional AppSec teams have become the DevSecOps team. And then we still had DevOps practices and potentially a DevOps team and DevOps engineers that were, in their own silo. And this happened at a couple of the previous employers and previous roles that I had. And in fact, it happens quite regularly where you have this conflict and this idea where, where does ownership lie? Is it in development? Is it in security? Is it operations? And there's this tension that, we tried to get rid of by introducing DevOps and DevSecOps and improving the communication. But in unintendedly, the unintended consequence of this was that DevSecOps just siloed everything. So if you look at the term, it's pure marketing witchcraft speak. Everybody's using the term DevSecOps right now, and also DevOps, but more so DevSecOps has become the buzzword, especially in the security tooling industry. And I think that what it's doing, again, is it's forcing these siloed approaches to how we implement and develop software. So if you find yourself with a DevSecOps team and a DevOps team, really, you've done something wrong. They should be the same. And this is one of the things that I did coming to Village MD was I wanted to break down the silos of application security. I came into the organization as part of the DevSecOps team, and there was disparate DevOps functions across multiple units, so organizational units. So we had, DevSecOps and security reporting to the CISO. We had cloud technologies, which put up product infrastructure as code, and there was DevOps there. We had DevOps happening in our enterprise technology organization, and it was really hard to get things done. Again, it comes down to communication, some of the best practices as we start looking at DevOps. And what I did was worked with all the other managers and directors and VPs and said, hey, let's merge this into one group. So now I'm part of this infrastructure and developer operations group. We handle DevOps and automation, cloud technology, database architecture, and database maintenance. We have SRE in that organization, as well as network and voice. And at first I was a little bit skeptical. I was like, well, voice and networking, like physical networking, what does this mean? And how does this really fit into this DevOps approach? And what I realized is that we can really apply infrastructure as code into our physical networking devices. So let's say we have a Fortinet sitting in a clinic somewhere. Have that thing call home and get the configuration from a central location and bring that down to the device. Now that configuration file, that can be part of our CI/CD process, and we can store that in our source code repositories and deploy that and apply testing and security checks to that. So we could look for specific network ranges or ports or things that are open and check for the quality of that configuration before it even goes out to our device. So let's pause for a second. We've talked about DevOps and DevSecOps and the siloization and some of the things that we can do, and then avoiding that communication conflict. But let's dig into a little bit of why and how security really is that element of quality. So I want to have everyone take a look at this number. So 4,467,098. And, it's a pretty big number. And, just in the context of what it is, it doesn't make much sense. But when we look at the reason for that number, this is the number of healthcare records that were compromised in January of this year alone. And that is remarkable. So when we look at the history of healthcare records that are compromised over the past year until February last year, or greater than a year, we see that September in 2020, we had almost 10 million healthcare records exposed. Now, this is people's personal health information. So, what kind of ailments you suffer from, your address, potentially your social security number. So PII and PHI is part of this compromised healthcare records. And the biggest source of the failures here were patching and IT misconfiguration, website and application hacks, and then unauthorized access and disclosure. So this is system quality. This is the quality of our systems that we deploy. If we're not patching our systems and they're out of date, we're really exposing them to a lot of vulnerabilities that hackers or attackers can use to take into consider, to apply and get access or unauthorized access to our systems. Just recently, as soon as I think it was this week, there was a healthcare organization in Indiana that was attacked and their systems were compromised. And what that resulted in was ambulances and emergency vehicles being turned away. This is actually transferring into people's safety and health. So because we're not applying these quality attributes to our systems, and security being that quality attribute, people's lives are at risk. Josh Corman, I'm not sure if anyone has seen him talk, but he's been talking for 6 or 7 years and has actually talked in front of Congress talking about these infrastructure hacks. And the warning that he gave was, this is going to be part of our daily things that we have to deal with in a security organization. And again, this is the physical effects of what happens in cyber. It's not just records. This is people's lives that are at risk. And so this is the graph of the healthcare breaches. So these are individual companies that got attacked in the last year. And starting in February, we saw 95 organizations in September of 2020. And that made up almost the 10 million records that were compromised. This is just unacceptable. We can avoid this. And again, it leads to the safety issues. And this all tell us that our application security and infrastructure quality sucks, regardless if it's security or not. If we look at how we develop software in our CI/CD pipelines, we treat breakages, let's say there's a business function that isn't working, as a bug. But when it comes to tracking security issues, those are just, logged or put aside or, just not addressed. If you do a security scan, a configuration scan of your AWS or cloud environments, you'll be surprised what you see. I was at an organization doing a security first AWS architecture. And when I did a scan, I noticed that there was a Minecraft server sitting in Dubai. And this was, an organization that was part of the government and government regulated. So technically things should have been in just US East 1, US East 2, West 1, and West 2 in Amazon for the US regions and for the US government. And again, there's a security issue with having something coming out of Dubai. And a lot of the default configuration for Amazon, especially, has open network ACLs for all of the regions and availability zones inside of the AWS infrastructure. So, one of the things that we need to consider there is when we do these scans, we're going to be expecting to see a lot of vulnerabilities come in. And then it becomes, how do I triage those? How do I get those into our work streams? And we have to treat work items or bugs the similar way that we treat security issues. So it's just something we have to do. So rather than separate those, I like to have them combined into a task or just something that we have to address. So again, security is an attribute of quality, and that's a period. We have to treat it that way. And we have to treat it the same way we do testing as much as we do checking along the process. And when we think about the systems that we put together to build our software, there's a quality issue there as well. We have to be careful about the third-party tools that we're using to assemble our assembly line. We start looking at things like Team City, and we have the SolarWinds attack, and a lot of that just came from things being messed around with during the build process. So it's not just our products that we have to secure and the code in our infrastructure. It's also the tools that come into our infrastructure to build our systems. These are like Trojan horses sometimes. Is part of another organization. I got a container, a Docker image from a vendor, and it just came past my desk, and I was in the DevSecOps organization or application security organization. And I decided to run some tests on it to see, were there any vulnerabilities in this product that the vendor was sending us? And it turned out there was 9 critical vulnerabilities that could be exploited very easily. So the question then becomes, how do we have the vendors address these issues and fix these issues? Because now we have the technology to look under the hood of what our vendors give us and really address the vulnerabilities or security issues that are in there. And that's part of their containerization and packaging process. So a lot of it was the quality of the components that they used. A lot of it was the patching issues that we see with healthcare breaches. And we're just not updating our systems as fast as we can. So it's time to innovate, right? And take a look at different ways to integrate security into our CI/CD processes and into our DevOps practices without creating a friction or introducing other issues. So I'm going to talk through a few different approaches to integrate and put some security related tooling inside of our development and manufacturing processes. So we need to solve security problems with engineering efforts. We have to have an engineering first approach to bringing security into our manufacturing, right? So how do we integrate security in a seamless way with little to no engineering impact? I put a stake in the ground before saying, if it's more than 5 minutes, developers are just going to yank the security controls out of their DevOps pipelines, right, or CI/CD pipelines. And that's something that happened before with my past experience, where we put something out and it was scanning a tool, or was a static analysis and security testing tool. And it was blocking all the other builds from going through because it was this massive, 4 million lines of code. Probably most of it was, either dead code or things that didn't go anywhere, or people checking in their third-party components, which we didn't really need to scan because we had the technology and other tooling that would be better scanned in, open source software scanning tools, software composition analysis tools. And we were using static analysis. And what happened was that control was pulled out and security organization wasn't informed. And you stop getting information about the security quality of your systems. You can't react, or you can't get ahead of these vulnerabilities. So what we want to do there is, instead of having that 5-minute stake in the ground, we have the technology now to scan for security in 5 seconds, 15 seconds, 50 seconds. We have to get to the point where the tool's mature enough. And the techniques that we use, we think essential about the controls that we put in, and really it comes down to flow from a DevOps perspective. How do we automate verification, analysis, and vulnerability management? So again, it comes down to the selection of how can we ensure that the tools that we put in place put information and get information on the dissemination side? How do we disseminate information to the right people? But how do we automate all of that so we don't have to have any interaction from a employee perspective or a team member that has to go in and say, okay, let me count all the vulnerabilities that we have across 100 projects, and using a calculator for this, it's just not effective. So we have to look at those areas of waste and say, how do we enable that information to come out of these development processes? And that's an engineering approach and an engineering function that we need to address. So this is where security and engineering really become a hand-in-hand or single point of solutioning for bringing these tool sets into the CI/CD pipeline. And so again, this is 3 ways that we want to be cognizant of flow. How do our products get to our customers as fast as possible without, with minimal interruption, and especially from security tools. Again, security tools traditionally take a long amount of time. And in the past 6 years, they've gotten a lot better, right? 6 years ago, we had these traditional security tools that took forever, and they weren't built to integrate into our automated processes. And that caused a lot of friction. And again, we got to get that out of there and treat it with modern technologies and implement the processes we define. Feedback is getting those feedback loops back to the developers. Before it was like, how do we do this? And a lot of questions were around, in our CI/CD process, how do we get breakages back to the developer as soon as possible? And that's one aspect of feedback. But the other aspect, I was talking to Patrick Dubois about this, is when we put applications out into the general population, wouldn't it be nice to have feedback from there to the developer, or to the business analysts and the product owners saying, the vulnerabilities that you have in the code that actually are in the application because you've either accepted the risk are utilized 90% of the time as users go through their user journey through the application. So getting that kind of feedback can help prioritize the issues and how they're fixed. And then, experimentation, that's part of the DevOps tenets, where you need to set time aside in the work week to innovate. And by taking away work time, innovation is fostered, so people can experiment with other ways of doing things or collaborate with other teams. One of the things that I did with my team is introduce 10% time, which is a common thing in some of the organizations and the bigger companies in America and across the world. But people work 36 hours a week and they have 4 hours of experimentation. And it goes back to what my grandmother said back in the day, that 10% of every dollar you make is yours to keep. And so 10% of every hour you work, in my opinion, is yours to use for experimentation. Again, laws of subtraction also helps us, reflect on the work that we do. And because we have limited time to do the work we do, we innovate and think outside of the box. So introducing security tools, it doesn't happen overnight. This is a Shewhart graph, and this is a quality control graph that's been used statistically for years. And this is the idea of introducing a software composition analysis tool. So again, the first time you might run a software composition analysis tool, you might see 10,000 vulnerabilities across all the components and different versions of the components. So again, we're trying to take quality components from our suppliers. Again, this comes back to that manufacturing graph that Edward Deming put together in the 50s, right? It's sending information to the suppliers and then validating the quality of those components coming in. So you're going to notice, like, this is an example of an initial scan coming up at 1250, and then we might have every day that amount might grow and might reduce as people remediate issues. But as we start addressing our vulnerabilities over time, we can get to this point where we have an upper control limit and a lower control limit for vulnerabilities. And this actually can be meshed with the bugs and defects inside the application. And as we're we're analyzing this functionality over time, and we can do this kind of thing in Datadog or any kind of analytics or monitoring tool, so we can start alerting when things get out of control. So if we notice we see June 1st on this graph, there's an issue and we're out of control, and then we start addressing those issues. So this is where you start scrambling and thinking or seeing what's out of normal. And that's really what we're trying to do here, is identify the normal state of our systems. Again, from a business functionality perspective, as well as security. And then if we see something below our lower control limit, then we know that we're doing well. And a lot of these control limits are automatically calculated based on some formulas. And this is what I'm implementing across the things that we're doing inside of our infrastructure and developer operations organization. So this is the network quality, the voice quality of the deployments, things from a quality perspective of our routers, coming all the way to our DevOps processes. It's really DevOps and infrastructure as code is shifting everywhere. We're using networking people from the traditional operation perspective, where we're looking at routing and quality of service, and we're bringing that into our cloud and getting to the point where we're defining a lot of these things as code. And because we do that, and because we have these automation controls in place, we can start looking at the control limits of our applications. So a couple different ways. How do we get to the point where we're integrating security into, and not just security, but compliance and policy validation into our code? This is an application that's part of the DevOps Kung Fu DKFM organization and an open source collective. This is called Domi. It's a policy as code enforcer. So this is looking for things such as the quality of our S3 bucket configuration. Do we have encrypted flags? Do we have versioning enabled? What kind of things are we looking at for, encryption of data at rest, and those kind of things. So there's a ton of different policies we can look at for AWS or things inside of Kubernetes configuration, Azure, anything as code. So we can use things like Domi or policy as code. This is based on Open Policy Agent, which is a great standardized way of asserting controls inside of our asserting controls that are being met. And this is compliance quality. So, this comes back to how we hook this up into our GRC tools and our, risk organization, third-party risk governance. So we have things like, Zen GRC or some kind of GRC tool. And, those say, thou shalt encrypt data at rest or something in a regulatory fashion. And when we take that, if we put it in front of an engineer, well, what does that mean, right? So we've got to translate that into engineering speak. It's like encrypt your S3 buckets. And this kind of enforcement, when people put a pull request in, these things get scanned. And if there's any issues or policy violations, we can warn people for 90 days or 180 days. And then we can lock it down saying, what? No more applications. We're just going to have people remediate these things. And this is the shifting left in DevOps and shifting left with security compliance quality. So Domi, for example, runs in 5 seconds, which is incredible. Again, this is taking the flow aspect of DevOps into consideration and making sure that, we're not introducing delays or lags, and we're also putting the results into the pull request information inside of the tools that developers use. So they don't have to go to Zen GRC. They don't have to go to another application like Jira. We don't even have to create a ticket for it. We have the log, we have the record, and we have the information inside of a pull request. So this helps us with the compliance of recording the issues and then remediating the issues right in the tools that developers use. Now, software composition analysis, you mentioned this a little bit earlier in this talk. This is the supply chain quality. So this is your third-party vendors bringing in tooling or bringing in components that make up your system. When I was at Sonatype, we did a couple of studies around the software composition analysis space, and it turned out that we found some data that said, 97% of web-based applications are composed of open source software. 3% is actually our developers knitting that information together to make our product. And then on the normal development web services side, 85%. So what that tells us is 3 to 15% of application development is done by your company, and the rest is done by somebody you don't know. So these are the suppliers, and it's really important that we take a look at that and say, okay, what are we bringing into our systems? Again, this is quality in a supply chain. It's a security related issue because we're looking for vulnerabilities, but it's really looking at the quality of the components that we bring in. High quality, utilized, and also looking at things like, has that component been in a stale state, not contributed to for a long time, and then all of a sudden there's a lot of activity. What's happening there? Is something being introduced that could result in ransomware of our systems? And it's happened before, and this is the state of the world that we're in right now. So again, know how your engineers work and work like them. So from a software composition analysis perspective, here we're looking at vulnerability summaries, and this is detected by Sneak. And we can fix, in this NPM application, a package.json file. So we have all these vulnerabilities, and we have upgrade paths. Dependabot does this for GitHub, where you'll actually create a pull request and say, hey, we're 76% confident or 90% confident that this isn't going to break your code. So you can easily upgrade it. You have the logging and the artifact tracking inside of it. And it allows developers to, again, fix things in the area that they're in. And if you have those quality checks, the regression tests, the automatic or automated testing, and the security checking, you can be confident or semi-confident that when you put things out into your blue-green environment that they're going to work. And if they don't, you have the ability to roll these things back. So again, this is how we develop software today. It's not the same as how we did it back in the day. And this, again, 85 to 97% of these vulnerabilities are automatically fixable with these pull requests. So a lot of the heavy lifting triage of these security issues, these quality issues, is taken care of us by the tooling. And that runs in about 50 seconds. So if you're checking in on a pull request, these scans just happen, and they happen very quickly, and they also happen out of band as well. So, you're only as good as your last security scan. And, when things are at rest inside of a repository, if there are vulnerabilities because the code hasn't been touched, we still want to know if there's any issues with those components so we can address them and fix them in case they get pulled in as a dependency, either inner source or outer source, into our applications in the future. The other thing we can do is we can look at commit quality. This is a DKFM project called Hooks. This actually checks for quality before things even get committed to the source code repository. It actually integrates with the Git application as a pre-commit hook. And you can also do post-commit hooks or other kind of hooks. So for example, in a Go application, this is actually hooks running on hooks. We do linting, we do testing, we look for cyclomatic complexity. If the complexity, and that's the maintainability of the code, if that's too high, the build breaks on the device rather than being checked on the server. So what this is almost like a sanitization where our SBOMs are created here. They're checked into our application. So our software bill of materials in Cyclone DX format, everything gets added to the commit before it even gets pushed to the server. So we're, again, checking quality of our code and our applications before we even put it in to our repository. We can even generate documentation. For example, in Terraform, we can use tfdoc to generate Terraform documentation, inject it into our README, and then commit the whole thing into our Git repositories. So again, this is commit quality, and we're looking for issues in the code that could be security themselves before we commit. One of the open source or SCA vendors, I integrated a step into this process that scans the code for the supply chain vulnerabilities before the commit happens. And if there's any binary compatible fixes, it will break the commit. So it won't commit the code. And it'll say, hey, there's these components that can be upgraded. And so you can upgrade them on the client side and then put them into the repository. So some pretty cool things. That runs in 3 seconds, depending on how many checks that you put in. Upwards of 30 checks, and it'll still run pretty quickly, maybe 5 seconds. And then again, solving security issues like an engineer would, this is looking on GitHub into a package.json file and actually showing the engineers what the changes are. So, these can be automatically created by GitHub Dependabot. This could be a third-party SCA tool that's looking through things, but you can very easily see right here, that we're upgrading version 6 to version 7. So major upgrades, caution there, 3 to 4. It's easier to do these incremental minor updates than it is to do these major updates. So this is a good reason for having these security tools in place to ensure that you're always near the latest, if not at the latest version. Because these latest versions have security fixes. They may have bugs or issues, but would you rather have security issues building up over time, or would you rather have something that potentially breaks the build and then you roll back to the previous version? That's the risk and the decisions we have to make. Can keep interruption to a minimum. So this is as things get closed. If you have a Jira integration, you close the ticket. So it's zero-touch ticketing for the engineer. Again, they stay in their environment in GitHub, and these are just records for compliance at that time. And then one of the important things is detecting sensitive data before committing. This is an app called Lucha from DKFM, and it'll look for passwords or AWS keys, Mailgun API keys. I think there's about 30 different checks that it does. Again, this is all open source, so if anyone's a developer out there, contribute, that'd be great. But this will actually look for these secrets before the commit, which is very important, because if we commit a secret into our GitHub or source code repository, it becomes part of our history. Even if it's not in the head or the current version, it's part of the history, and hackers will find it. They know our components and their open source components more than we do. And again, an internal threat of finding those secrets, we could be exposing PHI to people inside of our organization that don't have the permissions to see it. So the idea behind all this is catching the fish before they get to the ocean. And here's the gratuitous Deadpool reference that I put in every single slide. Before they hit the customer, we want to make sure that our defects are fixed. We have security quality, compliance quality, code quality, and business functionality quality before our customers get it. And then we want to be able to react quickly. All this DevOps practices and CI/CD, what we're really doing is conditioning our developers to push code out fast and address issues in a timely way. So instead of having a release every 2 weeks, as soon as a feature is done, you push it out. Because if, behind a feature flag if you need to, or a fix if you need to, everything should be ready for production as soon as it hits your master branches and main branches inside your source code repository. So again, put the tools in place, make sure they're operating in an efficient and quick manner. You're not introducing any disruption, and you're really enabling the quality as part of everything you do. So again, security is just part of engineering, and we need to think that way. We need to break down the silos of DevSecOps and DevOps and just say, we're engineers, right? When I first started developing, we didn't have DevSecOps or DevOps, and this is many, many years ago. And what we had was programmers, right? Full stack programmers, full stack developers, and we didn't have all these silos. And I think we need to get back to that and need to get back to these lean manufacturing concepts. So with that, thank you very much. Appreciate it. Hope you enjoy the rest of the DevOps India Summit sessions, and reach out to me on Twitter, connect with me on LinkedIn. Look forward to talking to you. And if you have any questions, definitely reach out, because I'm always willing to talk about things, and I want to hear your story as well. So thank you.